Hello there. Almost sort of wrapping up Thursday. My name is Arun Gupta. I work for Red Hat. This talk is about lessons learned from real-world deployments of Java EE 7. I've been doing Java EE pretty much last 15 odd years, since the very first release of J2EE 1.2 actually, which started in 1999. So I've been involved with the team itself from very first release. These are all experiences. Like Java EE 7 was released last year of June 10th to be specific. I've been working with several customers who have been using Java EE 7 in deployments. So I picked three very characteristic deployments on how they're using Java EE 7 particularly, how they're using the new technologies, and this is the lessons learned from that. Why they're using it, design patterns and anti-patterns. So you'll hopefully learn something from it. In terms of Java EE 7, if we want to quickly talk about sort of the three big themes, the first one, of course, has been developer productivity, providing a more cohesive platform using CDI extensively throughout the platform, giving you a lot more POJO-driven development, less boilerplate code. That's sort of the one big theme of Java EE 7 that has been pretty persistent all around. HTML5, is a lot more reality now. So things like WebSocket, JSON processing, more of async processing, whether it's JAX-RS, whether it's servlets, whether it's EJB, all over, providing a little bit more scalability of your application is again a consistent theme for Java EE 7. And then the last but not the least, which is again a very consistent theme for Java EE 7, is meeting enterprise demands, is enterprise edition. So meet your enterprise demands. Now, a couple of missing items over there. First of all was batch processing, which was a great work done by Spring, and then incorporated as a standard in Java EE 7. So that got in. And in addition, we added support for concurrency, which is the ability to spin up user threads in a container context, and a lot of good stuff over there. And JMS was heavily revised, which overly simplified on how you can create a simple JMS application. Now, this is not about Java EE 7 technology in the tutorial. It's more about what these applications were, what these deployments were, and how they were being used. So my very first example is about UNHCR, which is United Nations High Commission for Refugees. And what it does is, it's a UN agency that protect and support refugees all around the world. It could be either UN identifies such a need, or a country could ask for such a need. So it's kind of nice to know that Java EE 7 is using in such a nice cause as well. So the UN refugees actually get benefits through secure card wallets, and those wallets are issued to the refugees. The refugees can then take those cards and go to different point of services or ATM machines. Using that, they can either withdraw cash or they can buy products using from a specified predefined merchants. So really, running their day-to-day life is what these cards are used for. And one of the nice things about UNHCR is they've actually won Nobel Peace Prize twice. So I was particularly, that was my reason of getting excited that, hey, this is such an agency, which is what we are helping for doing Java EE 7 development. Quick overview of the technology diagram here as such. So if you look at it, on the top is like a merchant point of sale. So for example, this is where a refugee would go, swipe the card. They can say, okay, get me money or buy me the product. eFinance is the company, which is the consulting company that did the project for them. There's an eFinance switch, which basically goes and talks to different network authorization. Authentication happens over here using the authorization engine. And then there is a cart management system over here. There is a little bit of back office processing that happens where the cards, etc., are issued. And then, of course, all the data is at the back end as well. There is a full integration with the existing UNHCR database. You might want to make sure that the refugees are valid and they are approved and the project number and all those things are happening. Out of this entire technology architecture diagram, there are lots of different interfaces, mobile interface and things like that. But the key part over here being the part highlighted in red is what is being implemented in Java EE 7. So let's look at the technology right away. What is it that what components of Java EE 7 was being used in building this solution? Well, first of all, Java API for JSON processing, or JSR 353, was a new addition to Java EE 7. And the best part about that was it gives you the ability to do JSON processing as part of the platform itself. So they were using this to do notification to agents. There was no need to incorporate a third-party library now because it's part of the platform, and that's my general philosophy. When I'm building a Java E7 application, I look at what the platform or the application server already provides. If the application server does not have that capability, then look at a third-party library and bundle it. But now it's as a standard, so that third-party library was not required at all as part of building a Java E7 application. Batch processing, again, this was something, you were bundling Spring Batch, and it's not just Spring Batch, it comes with a barrage of jar files that you need to integrate as part of your application. But now Batch is part of the Java E7 platform. So they were using Java EE Batch to perform tasks like end-of-day task, where they want to do posting of account or generation of reports. One of the things about Batch is, it does not provide a scheduling API by itself. So in this case, what it was doing is, you were using EJBs, like singleton EJBs or stateless EJBs. With those, they were scheduling using add schedule annotation, and they were saying, okay, now I'm going to fire the batch jobs. Concurrency is another brand new addition over here. Now, certain tasks that were being done in the Java E7 or in this particular deployment, they knew that task is going to take a longer time to process in the background. So they were actually using managed thread pools, and they were using a implementation specific way to configure those managed thread pools, because there is no standard way right now. But at least they had an option of saying, create these threads in a container context. And when I say container context, I really mean your class loading, your security, your JNDI context is available in those threads, and then let it go run. Because now when you're running in those threads, then you can say, do a class load, class resolution, resolve a JNDI name, and those would work, which would not be possible if you were creating your own new threads for that sake. We talked about EJB a little bit. EJB was doing the heavy lifting on the backend services. They were using local EJBs, that means within a WAR file, and they were using remote EJBs. They were doing remote invocation across the WAR files. Now, we generally don't see any new project really using a lot of JAX-WS or using SOAP-based web services, but this works very well if you have a legacy integration system. So in this case, for example, UNHCR systems had a SOAP interface. So that's where JAX-WS fit very well, because it's part of the stack itself. So you just generate, you're looking at their WSDL, you generate stubs and artifacts, and you bundle the clients, which can directly talk to what the endpoints are. A little bit more in terms of JPA. Another new feature added to Java E7 is, in JPA, for example, you can already do name queries, which are basically pre-compiled queries, and gives you a little bit more efficiency over native queries. Now, with JPA 2.1, you have an ability to call into stored procedures. Now, this system was a greenfield development. So what they did is, there were several stored procedures already written to do some basic processing. So they just use the new stored procedure query, which is a new annotation added to JPA 2.1, to tap into existing stored procedures and do the invocation that way. Another new feature of JPA that was used over here. Now remember, I'm not talking about the complete system. I'm talking about how Java E7 technologies were being used. With JPA, we could always say, start with a database or your database tables. From that, generate JPA entities. Now with JPA 2.1, you can say, I'm a Java developer. I'm going to start with a JPA entity. I'm going to code my JPA entity. In my persistence.xml, I'm going to specify some schema generation properties. And what that means is, using those JPA entities, I can generate my corresponding database tables, or either as a SQL scripts or directly into the database. And that's what they were using to iterating over, because these guys are all mostly Java programmers. This was done on a tight budget, so they kept improving their JPA entities and generating their database schema accordingly. So this is how they handle change requests as well. So if somebody was saying, okay, change the database schema this way, so they would change their JP entity to reflect what the SQL is being generated, and then it was going into the database. Another new feature of Java EE 7 is how CDI was enabled by default. In Java EE 6, CDI was integrated, but you had to have a beans.xml. You won't realize how many, most of the time, 80% of the time, really, CDI errors were resolved if you just added beans.xml right there itself. No, injection not working. Well, you got to add beans.xml. So given that in Java EE 7, CDI was enabled by default. What that means is if you don't have a beans.xml, any bean with a CDI scoped annotation would automatically be available for injection. And that's what they were using. So they were defining different layers, like entity, control, boundary, and they were all talking to each other.
What was the original reason in 6 not to make it?
Well, the idea was, it's the first time it was introduced. A lot of CDI work was really coming from different technologies. If you enable it by default, the thought was, and this is the first time we were doing it, right? The thought was, oh, you know what, it's going to blow up, how many classes are going to get loaded. We want to define, we have a ER file. Within ER, you could have multiple war files. At what level you define, the injection needs to happen. So now, default CDI is enabled, but what that means is any bean with a CDI scoped annotation is available. Does not mean all the beans are available. But you can override that by adding a beans.xml in which there is another type attribute, like bean scoped attribute is there, which you can specify whether you want all the beans to be injected or annotated, which is the default, or you can turn off the injection by that beans.xml. So it's still there, but there is a default convention, which is sort of how the thought process of Java EE 7 is going. In general, we want to have a convention. I mean, if you saw Adam Bean's session yesterday, in general, we want to have convention in Java EE, but still there is a configuration option to override that. So those were the core Java EE 7 technologies that were being used. In addition, there were a few libraries being used. So the first one was, you need a JSF component library, because JSF gives you the ability to create, your front end, but it doesn't have a component library. That's not the business of JSF itself, or the implementation at least. And the reason they use prime faces is because these guys were all savvy NetBeans developers. So prime faces has great support in NetBeans. Specifically, like how you can start from database. From the database, you can generate JP entities. Then you can say generate my REST interfaces, and then from that you can say generate my CRUD pages, all automated in a very slick way. So in that sense, in Java EE 7 support is best, in my opinion, in NetBeans. I mean, I use all 3 IDEs, but it's really slick, really automates and simplifies a lot of things in NetBeans that way. So this is a generator plugin. So generator plugin is what I was saying. It takes with the JP entity, generate your RESTful interfaces, all CRUD pages are generated for you. So they had certain admin and operations page where they don't need any fancy interfaces. They just want to look at the object, either manipulate it or delete it or add it, and that worked very well for them. So again, as I said, we always have a limited amount of time, resources, and constraints. So they took it as is, generated those pages, dump it into the WAR file, and that worked very well for them. They also used jQuery stock library for the broader interface page, not these admin and operations, but other where all of the functionality was happening. So jQuery stock library was used. Again, no changes made to the jQuery itself, just the stock itself. In terms of runtime, GlassFish 4 is the reference implementation for Java EE 7. So this is what they used. I mean, they picked up this project a while back. GlassFish 4 was the only option at that point of time. They started with it and they just loved it. In terms of a deployment, they really took 2 instances, deployed them in their local data center. But now there is a mandate for them to use commercial application server. So in the Java EE BOF yesterday night we were talking about, there is still no commercially supported Java EE 7 application server. Yes, there is JBoss EAP. Yes, there is WebLogic. Yes, there is WebSphere. They're all on the way. But until then, they are still sticking on to GlassFish 4. Until there is a commercially supported application server that comes out. Java E7 requires Java SE7, so that's a straight, simple answer. In terms of databases, there were 2 databases being used, and those were, that's where the data was already existing, so there's nothing new that comes out over there. In terms of tools I talked about, they were using NetBeans 7.4. That was their primary IDE, and as I said, NetBeans is the best IDE. IntelliJ and Eclipse has done a good job, but still NetBeans really simplifies your Java E7 development in terms of the support it provides and how you can generate those wizards and everything else. Their particular reason was how it provides integrated GlassFish management support, how you can do deployment to GlassFish locally, remotely, debug. All of that support is just very seamless in there. And it definitely helps that the 2 teams, the GlassFish team and the NetBeans team, work in the same company. We talked about how NetBeans has many templates to start from. So you really look from your business domain perspective. You don't worry about it. What annotation should I write over there? Well, I don't worry. I just want to do a WebSocket. I'm going to say new WebSocket is going to take care of boilerplate code for me. I want to create a new CDI qualifier, so it generates a boilerplate code for me. So that's what is a good benefit of NetBeans. They also use the prime faces generator plugin. And they were using like jQuery and HTML5 features over there. So it provides that nice HTML5 templating where it says, I have a Chrome plugin. I'm just going to edit it and save it. There is no need to refresh my page over there. It's automatically going to push it. It's very subtle changes, but overall it simplifies. It removes those, so to say, annoyances in your entire development cycle, which makes it a little bit happier experience. So Muhammad Taman, he's Egypt Jug leader. He's also the JCP EC member. So he's the one who helped me with this story. He's the one who built the application. He was leading the project at eFinance company. So all credits really goes to Muhammad. There's a book blog published on how this is being used and other details. So if you want to learn more about it, I highly recommend that. All right, my second story is about miles2run.org. I'm a runner. This is my passion. So as part of Java 1, we organized an activity where we were encouraging all people around the world to run and log their daily runs. So that's what this application was. So you can literally go to miles2run.org, and it's a free distance tracker application. It's nothing fancy. There are lots of other fancy applications like Runkeeper and others, but here what you can do is you can track your daily runs, and the feature that we added is you can create a community run. Oh, I'm getting ready for a conference. I'm going to organize a community run over there. Call it a DevOps run, for example, and I'm going to tell people to come join it over here. It provides you a little bit of aggregate statistics and things like that. And it, of course, has those social networking features over there. Free is a given these days, I guess. This is a snapshot of the website. So if you go to miles2run.org, this is what you would see. And it kind of provides you some aggregate statistics here. So for example, it talks about runners, miles, hours, all this social brokering is there, and only social brokering is there because if you want to use your login password, there is nothing new that's there in Java E7 to enable that. But social brokering is also not a feature of Java E7 per se, but I'll talk about that. So the website was responsive, reactive. We tried to follow the usual modern web application design pattern because this was a brand new application that was written. So you can see, we provide some fancy charts, some aggregate statistics, some graphs, some calendars. So lots of different widgets were used, and I'll talk about those different libraries, how they were being used. In terms of the architecture, so at the top layer, this was a client HTML5 application. Like in the previous case, as you recognize, it was using JSF, one of the components that was baked into the Java E7 itself. Here, it's a HTML5 web application. So it's a very classical, your HTML5 web application with the JAX-RS backend, that sort of architecture over there. And we'll talk a little bit more details. So pretty much different components, so to say, different services were available. So there was authentication resource, activity resource, timeline resource. Timeline is basically you can see how the user is running and how the runs are being logged, for example. So everything was published as a resource, and then those resources were composed on a particular given page. And then there were different views. And how these views were generated, I'll talk about that in the next slide. And on the back end, we used 3 different databases. And I'll talk about what the purpose was served by each of the database. Now, if I translate that into a technology diagram, so on the front end, for example, we were using AngularJS. It's a single-page application, so everything stays on the same page, and you just keep refreshing whatever based upon where you click. We were using Twitter Bootstrap for styling, and D3.js is an excellent library for graphs. So we were using a different combination of what those libraries are good for, and that was being used on the front end. Using Thymeleaf is a HTML5 templating engine. I'll talk about that in a second. And everything was exposed as using JAX-RS, my REST endpoint. So JAX-RS is sort of the default way by which you do that in a Java EE application server. In terms of Java EE technologies itself, you can see most of the usual technologies were used. EJBs for my typical transactional logic, JAX-RS for my REST endpoint, JPA with MySQL. Bean validation was used in association with JAX-RS. Specifically, if you are trying to add your run, we were using bean validation with JAX-RS. That's again a new feature of Java EE 7, and we were able to leverage it very well. On the back end, we were using WildFly, which is again Red Hat's open source application server. Used to be JBoss, now is WildFly is the community version, and EAP is the commercial version. JDK 8 was being used, although none of the JDK features or JDK 8 features were particularly used in this, because Java EE 7 particularly requires just JDK 7, and that's enough for it. And in terms of the 3 different databases, MySQL, Mongo, and Redis were used. And all of this was deployed on OpenShift, so which is Red Hat's open source PaaS platform. So you can go to OpenShift, sign up for free, and say, I'm going to create a new instance of WildFly, not just WildFly, but a variety of other projects. So everything was completely managed. We had a test deployment and a production deployment. Sort of a CI/CD kind of a environment was set up already. So let's take a look. Now, in terms of the technologies, as I said, in terms of user interface, we were using Thymeleaf. Thymeleaf is a Java-based HTML5 template, which works very, very well because you design the application once. It works on desktop, mobile, and different interfaces. This could integrate very well with JAX-RS, for example. So I could create my JAX-RS endpoints, and from there itself, I could say, how I want my front-end pages to look like and generate. AngularJS itself was used on the front end to consume those JAX-RS endpoints. So we were using a mix of Thymeleaf and AngularJS for the front-end pages. For theming, Bootstrap was used, and if given time, I'll actually go to the website and show you. But you kind of saw a preview of what the website looks like anyway. Authentication was done using JAX-RS filters. So for example, you have a REST endpoint sitting up over there. If you log in, then once you log in, remember we talked about the login was only using the social brokering. So you could say Twitter, Facebook, Google. Once you log in, there was a JAX-RS filter. So JAX-RS filter is a new concept introduced in JAX-RS, where you could say, 2 concepts were introduced. First was filter, second was interceptor. Filter would allow you to look at the headers at client and server, request and response on both the sides. So we were using client-side request or server-side request filters as the request comes in, and if you're brokering using, say, your Twitter account, then we set up a JAX-RS filter, which would look at the request and then accordingly delegate to the appropriate Twitter API or Google API to authenticate with them. All the pretty graphs were done in D3.js and C3.js. The difference between these 2 libraries particularly is D3.js, you can really dig deeper, create very detailed graphs. C3.js is a slightly higher level API which simplifies your domain model a little bit. In terms of the middleware, we talked about the user interface part of it. In terms of middleware, very, very classical architecture. So EJB plus JPA services for RDBMS. Now, one of the new things that is introduced in the Java EE 7 platform is you don't have to use EJB if you don't want to. So you could take a POJO. On a POJO, you can put a @transactional annotation, and that POJO would be automatically done in a container managed transaction. Or you can take a POJO, you don't want all the methods to be transactional, then you pick and choose the methods, and then on that method you specifically put @transactional. So that's the way to do container managed transaction in Java EE 7. I mean, of course, you can do user managed transaction anywhere you want. All the different NoSQL data source to Mongo and Redis, we created CDI services for them so that, typically if you're calling a JPA data or a JDBC database, then you can inject your persistence context and do it that way. So here in this case, we were using Mongo and Redis native Java drivers, but we were using add produces clause, which was saying, I can inject my Redis driver, or I can inject my Mongo driver, and then that will give me access to my underlying. So that's what I meant by saying CDI services for data stores. Even though we were using JDK 8, but we were able to leverage the Runtime API for working with date. And there were some issues identified on how that works with JPA. So we have filed those as issues in the JPA spec. So hopefully that will be cleaned up as part of Java EE 8 timeframe. We talked about it. We were authenticating using various OAuth providers. We were using their respective client API. So like we were using Twitter API or Facebook API or Google API. But one of the things that we were looking over there before, a few weeks ago was to use Keycloak. Now, Keycloak is a project by JBoss which actually allows or simplifies your social brokering. So you could simply say that, I want to, from your perspective, you're using a single API, and then you can say which broker you want to use to connect. So you just need to provide your credentials, and it does the negotiation for you. So I think that's something cool to look at. And we were using SLF4j with logback for logging on the backend. Some additional libraries. So that was sort of my Java EE 7 component. You saw the user interface was a little bit different over there. We use Timeleaf template engine, as I said, for server-side HTML5 views. So in a JAX-RS code, you sprinkle your templating code, and that's the page that is being generated for you. Of course, we use OAuth providers. So whatever the OAuth providers were required, those are bundled as part of the application itself, actually on the server side. Runtime API, this was in addition. One of the issues that we were seeing is because this application was accessed worldwide. So for example, I was logging a run in California. Then I come to Europe and I was trying to access the information. The application was getting confused. Which time zone are you? You logged it in there and you're viewing it in there. Where should I show you and how I should do the database date time conversion? So for that, we use jadira.usertime. This is a user type, which allows us to store date as UTC in the database itself. So depending upon which time zone you are logging in, independent of which time zone you are logging in, you're using a standard data type, and which time zone you're looking in, you can see in that time zone. Because otherwise this was really messing up our graphs as well. So for example, I would log in California, I travel to Europe, I see my graph, my running day is missed. So this really helped us solve that problem. Of course, the database drivers for Redis and Mango were used, but as I said, those were really encapsulated as CDI services. And we were using heavily JUnit with Marketer for unit testing. Now, how many of you have heard of Arquillion? Okay, that's pretty much 90%, 95% of you. Well, we were using Arquillion for integration testing. So although this app was tested on WildFly only, but that's the benefit of Arquillion, because Arquillion really allows you to do a container-independent testing. And that's really one of my key components when I'm doing my CI/CD pipeline. Arquillion is a key component for me. In terms of runtime, as I said, we were using JDK 8. That was our runtime. WildFly 8.1.0, which was released, I believe, in May, actually. So this was our runtime, because this is a Java EE 7 compliant application server. We were having, so if you go on OpenShift.com, as I said, anybody can sign up for free. As a free sign up, you get 3 gears, what they say. So gear is your memory capacity and your disk capacity. Each gear gives you half a gig of memory and 1 gig of disk space. Now you get 3 free gears. You can install whatever you want in there. So this was literally running on a free instance. We have, and the good thing is, you can say, I want to install, I want to provision WildFly instances, and I want to provision them in a scalable manner. And then in that case, it will automatically consume those 3 gears. And how it will use? It will take the first gear, it will provision WildFly over there. It will take the second gear, provision WildFly over there. and then it'll take the third gear, automatically spin up a HA proxy, front-ending all of that for you. How many times you have tried to set up Apache mod proxy and your worker.properties file and balancer members, and it gets screwed up. I mean, I have a template where I look at it, copy paste from there, and that works. But if you want to start from scratch, it still requires a little bit of manual work. So this is pretty seamless then, that's how we were testing it, that's how we were running it in production as well. So if you go to miles2run.org, you are churning out some of the machines in OpenShift instance over there. In terms of data store, as we talked about, we were using 3 different data stores. So we could have used like maybe 2, but we thought, what is the best design pattern that we want to highlight out of this? So for example, all the business activities like user information, activity, goal, where we want to do query and things like that, that was all stored in the traditional RDBMS database. In this case, we use MySQL. Any timeline information that when the user is storing, where I run and what my dates are, those were all stored in Redis. And the reason is because in Redis there's a feature called as sorted sets, which says, okay, show me all this information automatically sorted. And that's how it stores it, or that's how you can render it as well. That was very useful for us. And then Redis also has something called as atomic counters, which says how many runners are available. So all that information was automatically stored. Atomic counter means you can really access it from, even if multiple users are trying to update it, Redis will take care of all the concurrency issues for you. You don't have to do your own locking or anything like that. So that's where we felt the Redis pattern was comfortable. Now in terms of MongoDB, because we were doing social networking over there in the sense, Arun is logging in from California, and there is another user logging in from France, but I need to give recommendations to this user from France, so I should not give Arun as a recommendation. I'm giving a geography-based recommendation. That's where MongoDB worked very well. So we were able to generate sort of, Twitter-style follower-following kind of recommendation. Excuse me. So this was very easily generated using MongoDB. So in this case, all the development was done in IntelliJ IDEA. And IntelliJ IDEA, if you would have asked me this question about 2 or 3 years ago, I would have said, IntelliJ IDEA is really sucky in Java E7. But they've really come a long way. And it's really cool, IntelliJ IDEA is very well, it's the best in terms of pure Java editing. And what they've done is they've taken all of that functionality and applied that to Java E7. You could see, for example, all the Java E7 samples which are on GitHub. You can literally seamlessly operate them and move around them in IntelliJ IDEA. So it's come really some cool features. And that's the reason IntelliJ IDEA was chosen over here. Git, of course, is a version control. So at the time, when we initially did the project, we did not have CI, but we implemented CI a little bit later. And the deployment mechanism is the one that we are putting in place, where we want to say, anytime I make a change, I want this to go through my CI cycle, automated acceptance test, and then automatically push the changes live on the web. So some of the features that we thought are useful over here, which is a wish list, so to say, for Java E8, support for NoSQL database. Now, I can say that that's not going to happen. That's not happening at all. Because when people talk about NoSQL, it's a wide range. Anything from Hadoop to Mongo to Redis, Cassandra, everything is a NoSQL. Now, JPA was possible because we were talking about RDBMS. So there were ACID constraints. Now here, there are no ACID constraints. As a matter of fact, for NoSQL, you actually relax some of the ACID constraints. And each NoSQL data store in that sense relaxes some of its own constraints. So there is no commonality on what to do. So there are experiments like Hibernate OGM that Hibernate community is running. There is a little bit of work that was done a couple of years ago in Eclipse link as well. But in Java E8, I have shaken the can multiple times, just to kind of get out of the comfort zone that is this the right thing to do. But in Java E8, this is not going to happen. Something else that we came out of this exercise was we want easy to add OAuth support. So JaxRS expert group is in Java E8 is already looking at how OAuth 2 support can be added over there. So that should really simplify, again, providing a little bit more seamless out-of-the-box experience. And then so we use Thymeleaf as a templating engine, but it wasn't easy. We have to really look at Thymeleaf and then integrate it with Java EE 7. So another key feature which is already happening in Java EE 8, which is good to know, is the MVC framework. Java EE already has component-oriented MVC, which is JSF, but now it's going to provide action-oriented MVC. So you can say, I know what my view model looks like. I know what my controller looks like. Let me plug in my custom view, which could be FreeMarker, which could be any templating language like Velocity or even Thymeleaf. That's it. The MVC framework in Java EE 8 requires only JSP and facelets to be supported, but there will be an SPI, so potentially somebody else could build a pluggable templating engine for MVC, like for a Thymeleaf maybe. All right. Now this project was done by Shekhar, who used to work for Red Hat, and I don't know, maybe I made him work too much, but pretty much finishing the project, and he left Red Hat and he joined a different company now. The good thing over here is, again, if you go to github.com, the project is completely open source. In this case, it's fully open source. So you can go to github.com/miles2run. Miles, number 2, run. The project is fully open source. You can check out the entire source code. You can look at JAX-RS. You can look at CDI services. You can look at Thymeleaf templating engines. You can look at all of those drivers and everything that we did. So take a look at this, because I was working with Shekhar on this very closely. But source code is available. Take a look at it. And this is the last design that I'm going to show you. So tippy.camp. Now, tippy.camp is a campground management application, which is actually where you can do reservations. So from two perspectives. First, from the campground management perspective. So let's say I run a campground somewhere in Europe. Then I can say, hey, I want a service where people can come to my website and make reservations. Okay, I want to provide a portal. I want a reservation. I need an email service. I need a notification board, things like that. And then the other perspective is where I have a family, I want to go visit a campsite. So I go on tippy.camp, look at what is available and things like that. Now, tippy.camp, that's exactly the website name, tippy.camp. They're targeting about 25,000 plus campgrounds in Europe. This website is based out of Europe. So initially they want to run out of Europe, but then eventually expand around the world. It's a very customer-friendly booking portal, and I'll show you that this design is very fancy. And there are a couple of varieties by which tippy.camp can be done. So for example, you can say, give me the software and install it in my data center, and I'm going to customize it the way I like it. Or you can say, I don't have the means and mechanisms to have a data center or provision it in myself, so give me an instance. It's a SaaS service as well. And in terms of SaaS, they charge you either €1 a day or $1 a day. So it's pretty cheap in that sense. So if you look at the design, the website is pretty fancy. So you can go to tippy.com. All these are very responsive designs. So you can see there's some videos over it. All of that is integrated. Lots of functionality in there. So for example, you can say, tell me about the campsite design, tell me about the schedule. This is for the campground owners. This is a campground editor. How my campground looks like, what's the lay of the land, what regions are available, green, brown, all those legends were followed. And this is a full checkout card that is available as well. Of course, as a campground owner, that's where you make money. So this is sort of some of the snapshots from the website. You can go to tippy.camp yourself and take a look at it. But in terms of the architecture diagram, as I explained earlier, this is the campground owner. So this was built as a simple HTML5 application. There you can do literally all the usual things like reservations, check-in, check-out, portal handling. There is an administration interface, different things that you can do. The application could be accessed, it's an HTML5 application. So desktop, mobile, iPad, all of those different devices can very easily access the application. Then from the traveler perspective, of course, you can access the application, which could be either hosted on-site on the campground or as a SaaS on tippy.camp data center. So here my traveler is accessing the website. So these are my two primary consumers of tippy.camp. In terms of technology, so if you look at it, this is, it was hosted on a Linux machine with Apache HTTPD as a front end. It used JDK 8. So again, JDK 7 is required for Java EE 7, but that does not mean you can't use JDK 8. And there are some fancy features in JDK 8 that can simplify your life for Java EE 7. So here, in terms of the technology, JSF was the front end, and I'll talk about some JavaScript libraries that were used as well. JAX-RS, again, is a key component that we have seen across all these different deployments. And the more I'm talking to people, the more I'm realizing that pretty much JAX-RS is the consistent component that everybody is using. Expression language was used in the JSF pages, to do all your pulling your beans and exposing them in the front end. For security, very standard terminology, JAS with JDBC Realm. And with the JDBC Realm, okay, who all is in the database, and those users are given access to the application accordingly. And I'll talk about how servlet was used. This is a very interesting use case of servlet here. JSON processing was again used over here, and no third-party libraries. So again, if you want to use JSON processing in the Java EE platform, it's a low-level API, but hopefully, in JSON binding, which is planned for Java EE 8, is a higher-level API. That's more like JAX binding, where you say, take a POJO, on a POJO put an annotation, and you do the mapping. Using JSON processing is a lower level API where you look at the JSON structure, you get the entire JSON object, raw object, and then you navigate through the object one by one. Give me the object name, give me the object value, or this is an array. So navigate through the array. So that's the way you operate on it. But still, there is no third-party library that is required. Concurrency APIs were used as well, and I'll talk about that, how they were being used. CDI, EJB, bean validation. So very standard Java EE stack, but the key part is a lot of components are available within the Java EE platform where things generally work out of the box. This is what we call as an entity control boundary pattern. I'll explain that in a second. But your CDI beans were used in a view scoped annotation. This is a new annotation that is added as part of the Java EE 7 platform. For PayPal, when you're making a PayPal, that's where your servlets were used. So, in the servlet, we were using, because when I'll explain that in a slide a little bit later maybe. The front end was using JSF with prime faces 5. Okay, so let's take a look at it in a little bit more detail. So in terms of presentation, very standard Java server faces with expression language. So that's how you pull your bean and talk to them directly from the JSF page itself. That's enabled by CDI. In terms of security, we talked about a JAS principle is obtained at the very beginning and then propagated and connected with the JDBC Realm on the back end. In terms of middle tier, again, we are using EJB for business boundaries. One of the consistent issues that I see is, people say, no, EJBs are still heavyweight. So get out of 2004, get out of 2006, get out of 2008. EJBs are not heavyweight. It's not in the specification for the EJBs to be heavyweight. Yes, the job was not done right, but that's what we knew at that point of time. Now, literally, if you want to do an EJB, you take a POJO. On the POJO, you put a single annotation. No deployment descriptor required. No home interface, none of that crap. I got a personal story for that. I joined Sun in 1999. For the longest time, my manager was telling me, Arun, I joined as a core test engineer, which is like, oh. So for the longest time, my manager was saying, Arun, you're doing core testing. Core testing is okay, but let's take a look at the components that are using core and write test cases based upon those. So for the longest time, I was pushing back. No, EJB sounds like very complex. How would I write an EJB? Why do I need to write 5 things, 5 classes just to get an EJB working? And remember, I joined 99, so this is J2E 1.2, very first release, which was just a terrible, terrible job for EJB in that case. So my mind cannot comprehend anything that is complex. I have to really simplify it. So the 5 classes weren't comprehending with my mind. 1 class, 1 POJO, 1 annotation, absolutely. So the main thing I want to say here is EJBs are overly simplified. If you want to do container managed transaction for a single class, use EJB. If you want to use container managed transaction for a method of a POJO, use a transactional. If you want to do that, that's absolutely fine. Servlets were used here with JSON processing. So when we were talking with PayPal, now they were sending requests. They were needing data in a JSON format. So that's where servlets were used to generate the JSON data and send the data to PayPal and get the response back. And SendGrid was used to send a whole bunch of emails. Now remember, this is tippy.camp. So the flow would be, you go on a website, you make a reservation, and then the email is being sent. So SendGrid is the API that was used for sending email. Now Java Mail is good, but SendGrid has some really advanced functionality that can allow you to schedule, and it handles the mail functionality really well. This is a camping website. So in this case, you want to expose your API to partners who want to build upon you. So Jaxoris was used in this case to expose the API to partners. Now, partner could be anybody. I want to build a custom application. I want to build my custom dashboard using this. So I could be a partner in that sense. A little bit more on the technology. On the back-end side, JPA and bean validation was used. So the advantage of that is on a JPA entity, you can put the bean validation constraint. When you try to persist it, when you try to update it, delete it, automatically, the bean validation constraints are kicked in. And if the constraints are not honored, it actually throws a constraint violation exception. So in your code, you don't need to say if value is null or if length of name is less than 30. You just put the constraint and your code is right away. You can read the code. If you can read the code, if you can understand the code, it's more than likely to work. And you get rid of those nasty if-else loops, a bunch of if-else loops. So to me, semantic readability of the code is very important. And that's what JPA and bean validation really gives you. A new feature added in JPA 2.1 is the @index annotation. Now remember, we talked about how you can take a JPA bean or JPA entity and generate your database from that. Well, when you're generating database from that, by default, it generates an index on the primary key. But what if you want to generate more index? So then you can start creating composite index keys that I want to index on multiple fields or a single field. So it will generate those additional index keys for you. Now, when we were using SendGrid for sending an email, now SendGrid it was excellent library, but because of the way SMTP servers work, it could take up to 1 to 4 seconds to send an email. So what was happening is, when the entire process is completed, at that point, we were using concurrency API. Now, in earlier versions of Java EE platform, you could not spin up a user thread. You could do it, but it's a violation of the platform, and the behavior is not consistent across different application servers. So now with concurrency, what they were doing is, as soon as the process is complete, they return the response to user that, okay, you are done. Expect an email in a few minutes or a few hours, whatever the SLA time is. And then they spin up a new concurrency user thread. That's where they were using SendGrid API to send an email. So that's a very good use case of how you would do it. And then there were there was also EJBs which had so this was basically done in a EJB which had a startup annotation. What that means is EJB will automatically get started, booted up when the WAR file is deployed, and it's a single instance of EJB. And it was schedule annotation. So every time you can check that, okay, if there is any email pending. If not, then it's good. If they're pending, then I'll send an email. In this case, this is not Java EE 7 requirement, but because JDK 8 was used, and you'll recognize, Adam Bien wrote this application. So he was using all sorts of JDK 8 features like lambdas, parallel streams, datetime API, which simplified the code a lot for him. So the general principles for he was using is all components were used with @inject. There is no @resource, anything of that sort, and that is the future direction. Highly recommend use @inject for it. If it's not working, use what is working for now, but make sure you file a bug on the spec, file a bug on the implementation. The future direction is absolutely CDI driven. Bean discovery mode is a new attribute that was added to beans.xml, and in that there is specified a value as all. And what that means is all the beans in the WAR file are available for injection. All the named beans were JSF 2.2 view scope. This is a new annotation. This is defined really as a CDI scope. So there's a new CDI scope added over there. So the JSF 2.2 Now, remember, JSF has been into existence for many, many years. It's a very mature technology. So it has done a lot of good things, but now CDI is kind of providing more standard way, a more cohesion across the platform. So in that case, the legacy annotations are being deprecated and more CDI-friendly annotations are being introduced. All boundaries are only stateless, so there is an entity control boundary pattern. There is no remote or local interfaces because everything is happening within the WAR file. So literally putting @stateless annotation is enough because it says, oh, this is a local EJB, everything is transactional, and we're going to go with that. So let's talk about the entity control boundary pattern. So, well, in terms of entity control boundary pattern, what that means is you define, this is what Adam Bien calls as microservice. This is his sort of one microservice, so to say. So you take, for example, here, Camp TP Business Messenger. So this is your one microservice, so to say. And then this is divided into 3 different functionalities. There is an entity, which is what your JP entities is going to be. Then there is a controller to it, and then there's a boundary to it. The boundary being the EJB or the business layer, which is going to be here. This is the controller. So you define that into 3 different packages. So here you can see messenger.boundary, control, and entity. I mean, you can define your convention, but that's the convention that he uses. So that becomes your one independent service by itself, which is operating on its own. So let's see what additional libraries were used here. In this case, prime faces 5 was used. So if you are using JSF, highly recommend using prime faces. I've used it in several of my pet projects. I just absolutely love it. And Bootstrap, was used for the responsive portal. I talked about SendGrid was used for sending emails. If you are using database migrations, so there are a couple of primary options, Liquibase and Flyway, but I'm seeing a lot more of Flyway being used for database migration. So I'm also planning to explore Flyway a little bit more. So stay tuned on my blog. I'll provide more details on how Java EE and Flyway would work with each other, for a broader use case. But the idea is Flyway allows you to document your database migrations either using Java or your script or the way you want it. And as you deploy, it automatically creates a version number in your table, and it makes your database migration problems a lot more simpler. There were some miscellaneous Apache Commons utilities that were being used. Hopefully they get added to the Java platform sometime. JUnit was used with Derby, which is a very lightweight database for testing purposes primarily. But in terms of runtime, JDK 8 was used, WildFly 1810 was used, and this code really comes from the customer itself. They just love the product. And from the relational database perspective, it was single database, which is MySQL. In terms of tools, again, IntelliJ is being used. As you know, this is very good for journal Java editing. Jenkins was used, and this is Adam Bien, so knowing him, this is all done using continuous integration style. So Jenkins was used. Loader.io was an API that he was using for all of your load testing. And this was hosted on Linux servers in a German data center. But the plan is to, again, move it to OpenShift in 2015, so that experimentation has been begun. If you are using WildFly, I highly recommend to take a look at OpenShift because that really simplifies your deployment, development options, and it provides a very seamless integration with IntelliJ and JBoss Developer Studio, which is an Eclipse-based tool. So the wishlist that came out of it for Java EE 8, Apache Commons library, either in Java EE or Java SE. Our goal should be to simplify the job of a developer. So where it goes, let the JCP decide that, but I want a standard API to use it. This is my pet peeve. In batch processing, when you do batch processing, I want generics to be there. This is a consistent pet peeve that I've seen actually all across. Right now, you can say reader, processor, and writer. They take string and objects like that. I want generics over there. So, okay, I'm going to operate on an input item, and the item type is a person or a book or a record. So that's hopefully will be solved in terms of the Java EE 8 timeframe. There is an add temporal attribute that you can add to your JPA field, but that doesn't work apparently with local date and local date time. So that's a minor issue. Hopefully it will be fixed in terms of JPA 2.2. And this is a quote again from Arun Gupta in terms of the technology. So he just totally enjoys. He's probably the best evangelist that we have for Java EE 7. So he's very, very productive with Java EE 7, and he really wants to change the world with Java EE 7. Wish him good luck. Christoph Gap is the person responsible for TippyCamp, and Arun Gupta, of course, is the architect for all of this. In case you are interested, there's a Java EE 7 tutorial for, it's a full-blown 600-page tutorial if you want to go end-to-end. But to me, really, the good way to learn is I prefer those simple hello world kind of samples. So this GitHub wiki has about 200 plus samples. These are not just samples on different technologies. So for example, 30 samples on WebSocket, 20 samples on JaxRS, 30 more on batch and things like that. These are also Arquillian tests. So each of the Java EE 7 technology is very well testable using Arquillian. So take a look at these samples, file an issue if something doesn't work. There's a continuous integration build running on WildFly where we test out these samples very regularly. So samples, integration tests, all of them, I think one of my best ways to learn. And of course, lots of books on it. And that's my last slide. I have a few minutes if you have any questions. Yeah, the question is, are the WebSockets not ready for production? Now, I gave a talk on Monday on nuts and bolts of WebSocket. There are few, the WebSockets are still, as I'm seeing, they're into the experimenting stage. People are playing it, they're liking it, but there are issues, specifically with firewalls and proxies, how they can even block the upgrade header. With WebSockets, when you start, you need to send a HTTP upgrade, then the TCP connection is held onto. It's not a scalability concern, but it's more like, what is going on the network which could possibly block it. So hopefully, things will improve, firewalls and proxies will become more aware of WebSocket. It's a shame that WebSocket became a standard in 2011 and is 3 years and still not into production. I really hope that changes. Yeah, well, I think the question is, anything in between Mockito and Arquillian to simplify integration testing for Java EE 7. Now, in general, Java EE 7 does not have a standard testing mechanism. Arquillian is one of the efforts, it's pretty much the only effort that I'm aware of, which allows at least a container agnostic Java EE 7 testing. So connect with me, talk to me, I'll connect you with Aslak, who's the guy who runs Arquillian. You, me, and Aslak can work on it together. See, what is it that we can simplify Arquillian? We don't want Arquillian to be pain in the neck or be slow to respond. If it is slow to respond, that's a bug.
Can you give an example why you would still need server-side templating in the second application that you mentioned?
It's just a different design. See, Java EE to me is a lot about offers, different offerings and different choices. You could choose different reasons. You could go with either servers, because the developer who was building Shaker, he was just familiar with time life. So he said, I'm familiar with time life. When you're making, how many times it happens that when you're picking a technology, it's purely your technology decision. Several times, it's like, this is what I'm comfortable with. I'm going to go with this. Given unlimited resources, unlimited time, I would probably put the ideal stack. And that's why it remains the ideal stack. So he was familiar with time leaf. Otherwise, we would have probably gone with just pure REST end and an AngularJS and a Bootstrap kind of a combination. Yeah, the question is, that's a very good question actually. Java EE has JASPIC, which is a dedicated module to do authentication already. If you look at this Java EE samples, which are actually tests, which is very, very useful, because the biggest set of issues are in the JASPIC modules actually. So Arjun Timms wrote a bunch of tests over there. Oh, awesome. Okay. Okay, there you go. So, well, you know the issues then. You know the issues, how it's not portable, how there are tons of problems over there. So yes, Jaspic is the right thing to do, provided it works. Excellent. Good to meet you in person. So you know the issues exactly. Hopefully we take care of some of them in the Java EE 8 timeframe. Right. Yeah. But we wanted to do something which is more portable. Yeah. Thank you, Arjun. Would you recommend to use Spring? See, to me, boy, I can go for 1 more hour now. To me, if you are deploying on a Java EE application server, my thought process is, Java EE application server is booting up. When it's booting up, it's giving you a lot of services, a lot of containers automatically. And when I say boot up, I really don't mean like 15 seconds. I'm not talking about WebLogic. I'm talking about WildFly and GlassFish, which are rapid to boot. So they boot rather rapidly in like 2 to 3 seconds. When the server is up, it's giving you a lot of services. Use them first. And it's giving you Java EE 7, CDI, JAX-RS, all those are in there, transactional. Use them. If something is not available in the container, then definitely look at Spring. One of the inherent issues is Java EE 7 being a JCP standard, it is slow to evolve. And that's by design. Spring probably is run by 2 or 3 guys who decide, okay, this is what needs to be done, just go for it. And I talked to several people around, they say, what, the reason we like Java EE 7, because there is a standard. And, complain it, be happy about it, but at least, we are stuck with the standard, and then we can tell everybody this is how you need to do. Spring, there are so many different recipes, we don't know what is the best recipe and things to do. So that's my recommendation. No means I'm bashing Spring. I think Spring is good. We need some implementation for growth, but that's how I see it. Okay, I think my time is up. You can always catch me today. Whatever time is left is today. Thank you very much.